Dear students, whether my screen is visible, am I audible?
Yes, sir.
Yes, fine, thank you. So, good morning, students. So, today we are entering the module 22, right, in the IC engine subject, right. So, in the unit of diesel engine, today we are going to see about the injection pump and the injector, right, that is the fuel injector, right. So before entering this class, just we can recap what are the terms we discussed in last class, right? So for the last class, we discussed the fuel supply system in the CI engines, right? So how the fuel supply will be there, right? How the fuel fed system will be there in the diesel engine, right? Then what are the requirements, right? What are the requirements are there in the fuel injection system, right? So what are the more major requirements, right? So that's we can see a general first we can see, right? So in the CI engines, only the air is sucked during the suction stroke and it will be compressed, right? So while compressing the air, right, so it will compress about 28 to 70 bar and it will generate 520 degrees Celsius to 720 degrees Celsius of temperature. That heat is uh, will ignite the fuel which is sprayed in the fuel injector, right? So the fuel injector also sprays the fuel at a particular pressure, right? So the pressure will be 100 to 200 bar, right? 100 to 200 bar, right? So you can note these three values. At the same time, we have to see the compression ratios also, right? So here the compression ratio, right? So these four are important one, right? These four has to remember, right? So while in the compression stroke, the pressure will be generated in the air is around 28 to 70 bar pressure. At the time, it will develop the heat of 520 to 720 degrees Celsius, right? So here only the air will be the compressed. So here the compression ratio also high, right? High compression ratio will be used in the diesel engines, right? So this heat is enough to ignite the fuel which is sprayed, which is uh, injected from the fuel injected, right? Fuel injection, right? So the fuel also injected in a particular pressure that is ranges between 100 to 200 bar pressure we have to supply, right? Thus here one more term, the ignition delay. What is the ignition delay? So the time duration between the start of the injection and start of the ignition, start of injection and start of ignition, right? So for the high speed engines, it may be 0.001 second, and for the low speed engines, it may 0.002 seconds. At the time, the crank rotation will be around 25-degree, right? At the time, the crank rotation will be around 25-degree, right? So these term. Then the requirements, right? So here the metering device, right? Accurate metering has to ensure, right, for each cycle of the rotation of the engine crank. At the same time, we have to see the very small amount of the fuel will be injected through the injector, right? So that we have to monitor closely, right? So the accurate metering device is very requirement, right? Then the timing, then the timing of the injection is also a very important one, right? So for the every cycle we have to get the maximum power by the ensuring the fuel economy as well as the clean burning, right? So that we have to ensure. Then the proper control rate of the injection, the same, right? Proper accurate metering is we have to see. Then the proper automation, right? Proper automation and proper the spray pattern and the uniform distribution of the fuel, right? So without dripping we have to supply the fuel and the equal amount, right? So we have to supply the equal amount of fuel in each injector for the functional requirements, right? Functional requirements of the injection system, right? Then the injection system will be classified into two terms. One is the air injection system, and one more is the solid injection system, right? So in that solid injection system, we have four sub classifications, right? So individual pump with a nozzle system, then the unit injector system, common rail injector system, or a distributor injection system, right? So these are the basic setup, right? These are the basic setup of the fuel feed system, right? So here the major parts will be the fuel tank, right? So from the fuel tank, we have to supply the fuel to the plunger feed pump. Here the pressure will be slightly increases, and it will be sent to again the filter, right? So here we are using the two type of filter. One is the coarse filter and the fine filter, right? So after getting some pressurized fuel from the plunger feed pump, again it will be sent to the fuel pump, right? Again it will be sent to the fuel pump, right? So after that fuel pump, the fuel will be sent to the injection pump, right? So here it is the injection. Then from the injection pump, the fuel will be comes to the chamber, that is the combustion chamber, through a nozzle. That nozzle is called as the injector, right? So these are the major terms, right? These are the major terms will be there in the fuel feed systems. Then last class we seen, right? See here you have injector, right? So different injectors, right? So each injector, right? Each injector, each individual injector will have a pump, right? So always the plunger pump, it is a low pressure pump will be the plunger pump, right? The plunger pump will increase the pressure, slightly increases the pressure, right? So but that pressure is not enough for the injection, right? So we have to generate more power, more pressure, sorry, more pressure, right? So we are using one more pump here, that is a fuel pump, right? So here the HP pumps will be the fuel pump. HP pumps will be the fuel pump. After that fuel pump, we have to supply the fuel to the injection pump, right? So here you can see the each pump, right? So every injector will have a separate pump, right? So the individual pump and the nozzle will be in works with the separate pumps, right? So this one type of the solid injection system, and here the pump will be in the separate place, right? So if it is the pump will be placed in single space, means that place is called as the cluster. The place is called as right. The place is called as the cluster, right? So here you can see the pump will be placed in single space, right? Then the second one is the unit injector, that is this diagram, right? Unit injector, right? So in this diagram you can see from the low pressure pump, the fuel will be fed into the directly to the injection pump, right? So there the pressure will be developed and the high pressure fuel will be injected to this nozzle, right? So here the each unit, right? So each unit will be there. So the line also a separate line, we are supplying the fuel to the separate line to the each injector, right? So this type of injection is called the unit type injection, right? So if the line will be common, right? So that type of system is called the common rail system, right? So here the header will be a common one, right? So from the header we have a fuel to the injection pump, right? So this type of system is called the common rail system, and we have a distributor, right? So the fuel will be comes to the rotor, which is rotating device, right? So it will be supplied to the rotor, and the rotor will be rotates, and the distributor having the different outlets, right? So that different outlets will be connected to the injection pump of each injector, right? So if it will be the rotor will be distributes the fuel in a different outlet, right? So each outlet will be connected through a one injector, two, three, like that the injector will be connected, right? So once the rotor will be rotates, right? So the amount of fuel will be supplied in a particular line of the fuel injector, right? So that type of system is called the distributor system. Then the injection pump, right? So here we have two types of the injection pumps, right? One is the jerk type pump, that is Bose fuel injection pump, and second one is the distributor pump, right? So here we can see the setup, right? How the setup will be there, right? So here we have a plunger, right? So here we have a plunger, right? The plunger movement will be in this direction, that is the upward and downward direction. The plunger will be moves, right? So this plunger movement will be controlled by some rack, right? So the rack will be movement by this direction. The rack will be in sideways direction, right? So here we have ports, right? So what is the port means? Supply one is the supply port. That supply port will be indicated as the A, and the spill port, will be denoted as C, and we have the outlet passage, right? So the outlet passage will be denoted as B, right? So in this diagram you can see, right, we have three ports, right? So one is the A port, that is the supply fuel supply port, and C is the spill out, right? Spill out port, and we have one more port, B port, right? So B port will be supplies the fuel to the cylinder, that is a combustion chamber, right? So if the fuel will be supplied through the A port, and what will happen? The plunger pushes the fuel, and the fuel will be stored here in this area. The fuel will be stored here, right? So at the time the spill port will be closed, right? At the time the spill port will be a closed one, right? You can see the after at the time the spill port will be a closed one, right? So once the plunger moves, right, once the plunger moves, what will happen? So the fuel will be stored here, right? So once the plunger will be pushes, what will happen here? It will generate the pressure, right? So that pressure will opens the valve, right? The pressure will be opens the B port valve, right? So always the B port will be connected by a spring, right? So what will happen? See this valve, right? So this valve will be pushes, right? This valve will be pushes by the pressure exerted by the fuel, right? So once the valve will be pushes, what will happen here? The spring will be compresses. The spring will be compresses, then the fuel will be goes into the outlet passages, right? So if the pressure will be reduces, what will happen? Slightly the spring will be closes the valve, right? So at the time what will happen? The plunger will be moves in a downward direction, right? Moves in a downward direction, right? So at the time, see here some opening will be happens, right? Here some opening will be happen. So the excess pressure, the high pressure will be goes to the uh, combustion chamber, and the remaining pressure, the low pressure, right? Remaining low pressure will be spills out to the tank, right? So here we have a three ports, right? One is the fuel supply port, and the pressurized fluid will be supplied through the injector, that is the outlet passage B port, and we have some the low pressure fuels will be get outs to the cylinder, get out to the fuel tank, that is spill out, right? So that port is called the spill out port, right? So this type of injection pump is called the jerk type injection pump, or a Bose fuel injection pump, right? And the second one is the distributor pump, right? So in this distributor pump, see here the center one, it is which is connected to the rotor, right? So the fuel will be supplied through the center rotor, right? So this is the center rotor, right? This is the center rotor, right? So once the rotor will be rotates, right? So these are the outlets, right? So 1 2 3 4 5, right? So these are the 5 outlets, right? So in this 5 outlet, what will happen? See, for example, here the inlet will be comes in the inlet port will be connected through the center rotor, right? So with this part will be a rotating one, this part will be a rotating one. So on the time what will happen? Where the opening will be there, there the fuel supply will be goes, right? So here you can see the fuel supply goes in this direction, right? So this type of the fuel pump injection is called the distributor type pump, right? So this type of injection is called the distributor fuel pump. Is it clear? Is it clear?
Yes, sir.
Okay, right. Then the fuel atomizer, the fuel atomizer or a injector, right? So the injection system will have a fuel injection pump and the nozzle. The nozzle is called the injector. The nozzle is called the injector, right? So here you can see, right? So how it will work means the high pressure fuel from the fuel pump will be comes into this chamber, right? So what will happen? The high pressure fuel will be comes through this passage, comes through this passage. You can see this passage. Are you able to see this passage? Right? So come to this passage, and here we have a valve, right? And here we have a valve, right? That is called the nozzle valve, right? So once the high pressure fuel will be comes to the this passage, what will happen? The valve will be pushes in the upward direction. The valve will be pushes in upward direction. So what will happen? The fuel will be passing through this nozzle, passing through this nozzle to the chamber, right? So this type of injection, right? It is the working of the fuel injection or a fuel atomizer, right? So the high pressure fuel will be passing, right? So the high pressure fuel will be enters to the bottom of the nozzle, the bottom of the nozzle, sorry, the bottom of the bottom of the nozzle, right? So here we have a valve, right? Here we have, right? So here you can see it is a valve, right? It is a valve, right? So once the high pressure fuel will be comes entrance to the bottom valve, what will happen? The bottom valve will be goes in upward direction, so it will creates a path, it will creates a path, and the fuel will be comes out to this orifice. That orifice is called the nozzle. That orifice is called the nozzle, right? So once the pressure will be gets down, what will happen? The valve will be against, it will be comes to the downward direction, so it will closes the valve, right? It will closes the valve and it will cut off the supply, right? So only the high pressure fuel will comes into the nozzle, means it will open and the fuel will be sprays. Otherwise it will cut off the fuel, right? Otherwise it will be cut off the fuel, right? So it will cut off the fuel supply to the engine, right? So in some cases what will happen means the high pressure will be passing through the chamber, this chamber, right? The spindle chamber, right? So on the time what will happen means the excess pressure will leaks through this chamber, right? That also will be collected from the outlet fuel passage, and again it will be sent to the tank. Again it will be sent to the tank, right? So the pressure, right? So the pressure will be controlled, or the pressure will be adjusted by the adjusting screw, which is connected through the spring, right? Which is connected through the spring, right? So what will happen? So on the pressure, right? When the valve will be open, right? At what pressure the valve will be open, that we have to adjust, right? That we have to adjust by the this adjusting screw, right? So it is a schematic diagram for the fuel atomizer or injector, right? So here the fuel atomizer or injector will be uh, classified, or it will be having a different type by the nozzle type. By the nozzle type uh, we can differentiate the different type of the injector, right? So here we can see the nozzle type, right? So the outlet passage is called the nozzle. The outlet passage is called the nozzle, right? So here we have a four type of nozzle, right? Here we have a four type of nozzle, right? So one is the single hole nozzle, multi hole nozzle, spindle nozzle, and Pentanex nozzle, right? So here we have a four type of nozzle, right? So it's a very simple one, right? We can see one by one, right? So what is the single hole nozzle? So only the single outlet will be there in the nozzle, only the single outlet, right? So the orifice will be a single one, right? So here I already told that we have a two type of the combustion chamber, right? This one is the combustion chamber, open combustion chamber, and the pre combustion chamber, right? So pre and the open combustion chamber, that will we can discuss in uh, later slides, right? So in the open, most of the this type of nozzle, that is a single hole nozzle, will be used in the open chamber type. Open combustion chamber type, we are using the single hole nozzle, right? So here the single hole, the diameter of the hole will be, it's around larger than 0.2 mm, 0.2 mm, right? At the time, the cone angle, the spray cone angle will be ranges from 5 to 15 degree, 5 to 15 degree, right? So the hole, the center hole will be considered here. Here the center hole will be there, right? So you can see in this diagram, you can see the high pressure fuel will be comes to this chamber, right? So this path, the high pressure fuel will be comes. At the time, what will happen? The valve, right? The nozzle valve, it is the nozzle valve. It is the nozzle valve, right? This nozzle valve will opens the path in this direction. So what will happen? The fuel will be comes through this pathway, right? So here the fuel will be injected, right? So here we have a small gap, right? The gap, it's around 0.2 mm. It's sorry, for the single hole system it will be larger than 0.2 mm. At the time, here the shape, right, the cone shape, the cone angle will be 5 to 15 degree, right? So most of cases, this cone gives a series of the spiral grooves, right? Series of the spiral grooves. It will impact the rotational motion of the fuel for the better mixing of air and the fuel, right? So here we have some advantages. Its construction is very, very simple. That's a major advantage for this one. And here we have some disadvantages too, right? So what means, so here we are using only one nozzle, one hole, right? So the very high pressure is required for the whole passages, right? Because we are using only the single hole, right? So because of this single hole, because of the relative fuel velocity, it requires the high fuel velocity, right? High fuel velocity. So the pressure also, we require high pressure. Then it will it will tendency for the dripping. It will creates, it will we cannot avoid the dripping, right? So the dripping also affects the fuel economy and the performance of the engine, right? So the dripping will be, it may forms, right? It tendency to for the dripping, right? So here we are using the spray angle around 5 to 15 degree, right? So the 15 degree will be the narrow one, right? So very narrow, right? So what will happen? It will not create a good mixture, right? It will not create a good mixture of the fuel and air, right? So these are the disadvantages of this type of the single hole nozzle, right? So in the case of the multi-hole nozzle, right? So what is the difference between single hole and multi-hole, right? So here we are using only one hole. For the multi-hole angle means we have different outlets. We have a multi outlets, right? Here we have a multi outlets, right? So this type also we are using in a open chamber, open combustion chamber. We are using this type of the multi-hole nozzle, right? So most of the automobile engines we are using this type of nozzle, right? So this type of nozzle we are using in most of the automobile engines, right? So it mixes the fuel and air, right? When it is low air movement available with the open chair combustion, right? Open combustion chamber, right? So here the number of holes, right? So for the multi-hole, so here the hole ranges will be 4 to 18, 4 to 18, right? So if the number of holes will be greater, if the number of holes will be greater, so the fuel distribution will be somewhat good, right? So if if the number of holes will be higher means, so what will happen? It will provides a better fuel distribution. It will gives a better fuel distribution. At the time, the hole size will be its range of 0.25 mm to 0.35 mm, and the spray angle, the cone angle, that cone angle will be 20 degree to 45 degree. That, so you can easily compare, right? So for the single hole, the diameter will be 0 point larger than 0.0, sorry, 0.2 mm, and here you can see the whole diameter will be 0.25 to 0.35, and for the single hole we have only one hole, but in the multi hole we have the range of 14 to 18 holes will be there. So if we are increasing number of the holes, it will helps to give a better fuel distribution, right? It will provides a better fuel distribution. At the same time, here the cone angle will be increases, right? So here it will be 5 to 15 degree, and here it will be 20 to 45 degree, 20 to 45 degree, right? So here also we have some here also we have some um, advantages and the disadvantages, right? So it will give a good administration, and it will distribute the fuel, right? It will distribute the fuel in good manner. Why? Because here the number of holes will be high, right? So greater number will provide the better distribution, right? Then what are the disadvantages, right? So the holes are very small, right? The holes are very small and it's liable to clogging, and the dripping between the injections, right? So here also the dripping will be there, even the single hole and the multi hole. So the major disadvantages will be a dripping one, right? Then the same disadvantages will be there, right? So here also we require the high pressure and the dribbling will be there. So here also the dribbling there and the high pressure will be there. Then the while making this type of the nozzle, the close tolerance has to create, right? While making the very small holes, right? So the machining will be somewhat difficult. Then the tolerances here we have a very close tolerance we have to see, so the machining cost will be high, right? So we have to precise machining we required, so the cost will be high for the making of this type of nozzles, right? Then the spindle nozzles, right? So these two nozzles, right, single nozzle and the multi-hole nozzle will be used in the open chamber, that is open combustion chamber. But in the spindle nozzle, here we have some extra projection, right? Extra projection, right? So that projection is called pin or a pintle, right? That is called pin or a pintle, right? So here you can see, so this is the nozzle, this is a nozzle, this nozzle will have some extra projection, right? So you can see here the extra portions, right? So here we have see a gap is there, and here we have see some gap is there, right? So this is the nozzle, right? It is the nozzle, right? It is the nozzle, but the nozzle and the nozzle body will have some gap, right? The extra gap, that extra protrudes will be there, right? So that the extra protrudes is called the kindle, right? The extra, see, the extra protrudes, it's called the spindle, right? So its shape may be a cylindrical one or a conical shape, right? Its shape will be a cylindrical or a conical, right? So in this diagram we can see here it is the conical one, right? It is a conical shaped spindle, right? So what will happen means this type of shape will increases the uh, cone angle, right? It will increases the cone angle, right? It's generally about the 60 degree, right? It's generally about 60 degree, right? So for the single hole and multi hole we can get only up to the 45 degree, but in this type of nozzle we can get a 60 degree um, cone angle, so the spray will be somewhat wider, so the spray will be somewhat in wider direction, right? So the distribution will be somewhat good, right? So here also we have some advantages and disadvantages, right? So what are the advantages means, so the self cleaning type, right? So this type of nozzles will be the self cleaning type, so it will prevents, right? It will prevents some the depositions, some the what are the exhaust deposition, that is the carbon depositions on the nozzle, right? So it will uh, yeah, sorry, it will prevents, right? It will prevents from the carbon, the exhaust depositions, and it will avoid some weaker injection and the dribblings, right? So last two nozzles, right? Either the single hole or a multi-hole nozzle. So the major disadvantages is dribbling, right? So here we can avoid the dribbling, right? Here we can avoid the dribbling. So the atomization is somewhat good here. Here the atomization is good, and the injection characteristics, right? The injection characteristics is more, right? So it is a greater advantage of the spindle nozzle, and the disadvantages is the distribution and the penetration. Distribution and the penetration is very, very poor, right? So it is not suitable for the open chamber. It is not suitable for the open chamber uh, system, open chamber cylinders, right? So in the diesel engine we are using open chamber and the pre-chamber, right? So it is very suitable for the pre-chamber one, right? So that first two nozzles will be used for the open chamber, and the spindle and the Pintex nozzle will be used in the pre-chamber, right? So the same, right? So the spindle, here we have only one outlet, right? Here we have only one outlet, but in the Pintex nozzle we have plenty of nozzle outlets, right? So here you can see the auxiliary holes, right? Here you can see the auxiliary holes, right? So the remaining and all the same, the remaining and all the same, but here we have one more hole, right? So one more hole, that hole is called the auxiliary hole, right? The auxiliary hole which is sideways in the nozzle, right? So why we are using this means it is better, it is good for the cold starting one, right? It is good for the cold starting performance, right? So the same disadvantages will be there here also. The distribution, here also the distribution is somewhat poor, right? It is not used for the open chamber, right? It is not used for the open chamber, right? So these are the injection pump and the injector, right? So in this injection pump we have two types of injection pump. One is the jerk type injection pump, and one more is the distributor injection pump. And for the injector, right, so injector means here the outlet nozzle is called as the injector, right? So we have four type of nozzles, right? So what are the four types of nozzles? A single hole, a multi hole, and the pintle and the Pintex nozzle, right? So we have a four type of nozzles, right? So we can stop here this class we can stop here. So we have afternoon class, right? We have afternoon class. In this afternoon class we can see the spray formations and the combustions, right? The spray formations and the combustions, right? So what is the time? Okay, so still some 5 minutes are there, right? So we can finish up the spray formations also, right? Say you can see the spray formation, right? So here we have plenty of diagrams, right? So at the start of the fuel injection, the pressure differences across the fuel injection and the orifice is very, very low, right? So therefore the single fuel droplets are formed like this. You can see the first diagram. So the fuel droplets will be in the single droplet fuel will be droplets will be formed, right? So at the start of the injection the pressure difference occurs, right? The pressure difference across the fuel injection and the orifice is low, right? So there we can get this type of the spray. The fuel will be in a single droplet formation, right? So this one type of formation, right? Then as the pressure difference increases, so we can get the other type of the formations, right? So the stream of the fuel emerges from the nozzle. The fume of sorry the stream the spray, right? The spray stream of the fuel emerges from the nozzle. We can get this type of spray, right? So the initially what will happen? So due to the pressure difference, right? Due to the pressure difference, low pressure difference, we can get fuel will be in the single droplet. If the pressure differences will be increases, if the pressure difference will be increases, so what will happen? The stream will be, right? So this stream will be produces, right? So if the pressure will be increases, this type of stream will be gets, right? So for the second diagram, right? Then the stream will be encounters aerodynamically, right? The stream will be encountered the aerodynamic resistance. It will forms, right? It will forms the dense air present in the combustion chamber, right? The dense air present in the combustion chamber, right? So in the combustion chamber we can get combustion ratio is around uh, minimum of the 12 to 14, minimum of the 12 to 14 the compression ratio will be there, right? So and it will breaks into the spray at the distance of this distance, that is here the nozzle outlet is there, right? So from here to here, from here to here, right? So after the stream will be developed like this, the stream will be developed like this, right? Then with a further increase of the pressure difference, right? So first what will happen, if the pressure will be low we can get a small droplets. After that it will increase some pressure, so the fuel spray will be in the stream manner. Again the pressure will be increases, the spray will be like in this manner. Then again the pressure difference will be somewhat more, right? It will break up the distance, right? It will break up the distance of the fuel, right? It will break up the distance of the fuel, and uh, the distance will be decreases, the distance will be decreases, and the cone angle will be increases, and the cone angle will be increases. You can see here, if the pressure will difference will be somewhat high, right? So at the time what will happen, on the time, see, you can see the formation will be like this. So the stream distance will be a breaks, the stream distance will be the breaks up, right? So this type of spray will be gets formation, right? This type of spray will be gets formation. And the velocity of the fuel is very very important one here. Here the velocity of fuel, that is the velocity of the flow, the velocity of flow, it's around 400 meters per second. The velocity of the flow, it's around 400 meters per second. And the velocity of flow will be calculated by the formula, right? So vf, which is equal to CD, right? What is the CD value? You may study it in fluid mechanics. What is CD? What?
Convergent divergent nozzle, sir.
Convergent diversion nozzle coefficient of the discharge. படிச்சிருக்கீங்களா வெஞ்சுரி ஆரிஃபேஸ் மீட்டர்ல படிச்சிருப்பீங்க, ரைட்டா? So what is the CD value? The CD is the coefficient of discharge. That is pressure inlet and the pressure cycle, that is injection and cycle, divided by the density of the fuel, right? So the velocity will be calculated by this formula, right? So CD square root of 2 the pressure of injection and the pressure of the cycle, that is the pressure of the cylinder, right? So the pressure differences, right? So I always told that, so if the pressure difference will be low, what will happen, the fuel formation will be in the droplet, right? So if the pressure differences will be somewhat high, so on the time you can get the stream, right? So whether the pressure difference will be still high, so on the time you can get this type of spray, right? So here also we can see the cutoff, right? இங்க தெரியுதா உங்களுக்கு அந்த இது இமேஜ் தெரியுதா? கொஞ்சம் இப்படி மேலே சின்ன சின்ன பிரேக்ஸ் தெரியும், இமேஜ் தெரியுதா? சின்ன சின்ன பிரேக்ஸ். லைன்ல இருக்கீங்களா? தெரியுது இல்லையா? சரி, அந்த சின்ன சின்ன பிரேக்ஸ்ன்றது என்ன அப்படின்னா, பிரஷர் டிஃபரன்ஸ் அதிகமாக அதிகமாக நமக்கு என்ன ஆகும், சின்ன சின்ன பிரேக்ஸ் வந்து ஃபார்மேஷன் ஆகும், ரைட்டா? ஸோ அந்த பிரேக் சின்ன சின்ன பிரேக்ஸ் ஃபார்மேஷன் ஆகுறது தான் இங்க என்ன ஆகுது, இங்க வந்து ஒரு பெரிய பிரேக்ஸாவே நம்மளுக்கு ஜென்ரேட் ஆகும். இங்க தெரியுதா, இந்த இந்த ஃபியூல் நாஸ்ல பெரிய பிரேக்ஸா இருக்கும், இங்க வந்து சின்ன சின்ன பிரேக்ஸா இருக்கும், ரைட்? இதெல்லாம் எதை பேஸ் பண்ணி இருக்கு, இந்த பிரஷர் டிஃபரன்ஸ், ரைட்? பிரஷர் டிஃபரன்ஸ் அப்படின்றது என்ன சொல்லியிருப்போம், the pressure of the injection, the pressure of injection, the pressure of the combustion chamber cycle, ரைட்டா? ஸோ இதுதான் என்ன சொல்லியிருப்போம், the pressure difference, இதுதான் pressure difference, and it will be, இதுதான் வந்து வெலாசிட்டிக்கான ஃபார்முலா. So the velocity of the flow will be, it's around 400 meters per second, right? So coefficient of discharge, every nozzle will have some coefficient of discharge இருக்கும், right? ஆரிஃபைஸ் நம்ம கண்டிப்பா நமக்கு coefficient of discharge இருக்கும், right? So அப்போ இங்க வரக்கூடிய pressure difference அதை பேஸ் பண்ணி நமக்கு வந்து spray formation இருக்கும், right? And one more formula is also there, right? So quantity of the fuel will be calculated, so that we can see in the next class, right? So the spray formation மறுபடியும் நம்ம next class பார்ப்போம், ஓகேவா? So do you have any doubt in this class? Do you have any doubt?
No, sir.
No. So right. So again